Hello and a warm welcome to all our participants from different parts of the world. This is Helen from the International Marketing Department. We are delighted to have you all with us again. Today we will be exploring the demands for campuses and the ICP DAS product lines that can help meet these needs. We will cover 3 real-world examples showcasing how ICP DAS solutions assist in monitoring and managing power consumption of the dormitory, controlling multiple sets of equipment, ensuring campus safety and server room security, and efficiently monitoring campus streetlights. Before we begin, I want to remind everyone that there will be a 5-minute break between the first half and second half of the webinar. And there will be a live Q&A session at the end of the webinar. So please feel free to leave your questions in the chat room. Now, let's begin. With rising power bills globally, schools and universities are seeking ways to monitor power consumption and reduce unnecessary usage. This can be achieved by acquiring and collecting power data from each facility and implementing centralized control of indoor lights, air conditioners, and outdoor streetlights. Besides managing costs, there have been alarming incidents of intruders on campuses and even attempts to harm individuals. Ensuring safety and security has become a major concern for school staff, students, and parents. At ICP DAS, we provide one-stop solutions to effectively address these critical needs. Our offerings include both wired and wireless energy management solutions, covering data acquisition, transmission, and management software. Additionally, we provide products for safety and security management. We offer environmental monitoring products, including various sensing modules for gases, weather information, and liquids. Additionally, we provide centralized lighting control using a wireless Zigbee network, a wired network, or on-site HMI devices. Our solutions also include SCADA software for remote and scheduled light control. The first case study is Dormitory Energy Monitoring System. Let's look at the application background and how we tackle the challenges. The university dormitory consists of 5 buildings with 108 traditional power meters. Management reported being burdened by the manual transcription of electricity usage and bill calculation for each room. This process, required every month, is extremely time-consuming and often causes errors. To address this, we installed our smart power meters PN3114 and PN3133 alongside the existing 108 single-phase and 3-phase traditional power meters for networking purposes. The power meter concentrator collects data from dorms A, B1, B2, B3, and E and facilitates data transfer to the control center, enabling centralized monitoring of each room's power consumption. For wireless communication options, we offer the PMC 5231N4GE. The smart power meters that come with clip-on current transformers ensure easy installation and uninterrupted power monitoring. 5 power meter concentrators collect data from 5 buildings each. They automatically send data log files to the control center with a built-in data recovery mechanism. Besides, if you don't have SCADA software, our power meter concentrators still allow you to check power information and reports on a web browser. The trend and pie charts, as well as essential power data, are shown right here. The network integrates seamlessly with the third-party responsive web design for centralized monitoring in the control center. Once you click on a dorm, the information on each room's daily and monthly power consumption will pop up. Users can efficiently manage devices by selecting PNC, power meter, and loop for browsing and centralized management. Users can select the period, input the cost per kilowatt hour, and export the report into the CSV file. Power bills for each room are automatically calculated. For example, room 101 has to pay $282, while room 104 has to pay $148. This system resolves the manual transcription and calculation issues. Isn't it very time-consuming and convenient? Now, we have a question here. What if the campus needs to manage a large number of PNCs installed across a vast area? The management software requires functions for remote firmware updates, remote control capabilities, and scalability of the existing network. Well, this is where IoT Star comes into play. IoT Star is the cloud management software developed by ICP DAS, designed to efficiently manage a large number of our edge controllers, PMC and PND. No programming required, it's entirely web-based. Simply enter the PC or IP address to get started. Its basic version supports up to 50 ICP DAS PNC or PMD, with upgrade options available to manage more. Remote management is easy with IoT Star, regardless of the network environment, mobile network, dynamic IP or virtual IP. PMC and PMD can be accessed via the IoT Star web interface. Besides, with just one click on the web page, you can complete firmware updates for multiple modules accordingly. IoT Star also automatically imports sensor data into the database, and IT personnel can write SQL commands to control I/O modules connected to PNC and PND. Managing devices becomes very convenient with IoT Star. Here is the user interface, a full-featured web page for managing time, network, security, COM port interface, and firmware updates. The tabs shown at the top include System Setting, Module Setting, Logger Setting, IoT Platform Setting, Advanced Setting, Route Setting, Channel Status, and IP Camera Status. This is the dashboard that shows energy consumption, carbon emissions, and comparisons between selected periods. On the right, we can see that the user interface can be customized to your preferences using the drag and drop feature. IoT Star also offers an optional service, the bot service. With this feature, management personnel can use mobile devices to check channel status. For example, they can click on a channel and then toggle light 1 on or off remotely. Additionally, users can monitor events and view snapshots taken when doors are open. This ensures staff can access real-time information anytime and anywhere, making monitoring solutions even more comprehensive. Let's quickly recap the ICP DAS energy management solution, from smart power meters and power meter concentrators to our powerful cloud management software, IoT Star. We offer a unique three-layer solution. The edge computing layer reduces the load on the cloud and enables faster response at the edge to control sensors and I/O modules. The cloud layer offers massive storage space, high scalability, and allows you to monitor, update, and control devices from anywhere at any time. In addition to the web-based operation and power data reporting we highlighted earlier, one distinctive feature of our PMC is its demand forecasting function. Organizations must manage their power usage to avoid exceeding contract capacities, which will lead to increased rates and costs. Our PMC's demand forecasting function predicts power consumption 15 minutes ahead based on historical data. If forecasted demand is expected to exceed the contract capacity, PMC can send notifications via email, SMS, or line, and automatically initiate unloading to prevent penalties. Conversely, if forecasted demand is significantly lower than the contract capacity, additional equipment can be activated to enhance productivity. The PMC and PMD series are specifically designed for power management, working with smart power meters to activate or deactivate equipment as required. The PMC functions as an edge controller, executing if-then-else logic control. For instance, when the classroom schedule indicates an empty class, the PMC 5231 instructs the PM3114-100 to turn off the air conditioners, thereby conserving energy. The power meters PM3114-100 monitor air conditioner power consumption on campus. It receives commands from the PMC 5231 to unload air conditioners when the power consumption exceeds a certain limit, thereby preventing high costs. When it comes to choosing modules and products, a selection guide can make the process much easier. Here it is, from loops, LED display, and current transformer sizes to reporting and management software. You can find your ideal ICP DAS power management solution with this quick guide. In summary, the holistic solution enables campuses to achieve centralized power monitoring and control, reduce manpower requirements, save energy and cost, and manage devices remotely. Now, let's move on to the Smart Campus Transformation case study. This comprehensive solution includes controlling office equipment and lights, as well as ensuring the security of the server room. A university campus was experiencing high electricity bills and inefficient light management, and wanted to strengthen the security of the server room. Therefore, a monitoring and control system was created, covering the office, server room, guard room, and control panel. The data collected from each area is transmitted to a PC with Intusoft installed, where a SCADA system is built. First of all, let's explore what we have in the office. We have modules for light control, motion detection, equipment control, access control, environmental monitoring, and data display. And let's see some highlights of the monitoring system in the office. The motion sensor module, PIR130, installed in the office, detects human presence or motion and features a power relay output for automated light control. In recent developments, we introduced the PIR234 module with enhanced detection sensitivity. The module has 4 passive infrared sensors to ensure that no motion goes undetected. Besides, these modules can detect humidity and include a 1-channel temperature sensor. This sensor can measure room temperature or be configured to activate a fire alarm, offering a cost-efficient solution. For the PIR234 series, the 2 series shown on the left are our high sensitivity types. They feature 4 passive infrared sensors and can detect motion up to 4 meters high and 40 meters wide, with 2 optimal sensitivity ranges available. On the extreme right, we offer a long-range type that can detect motion up to 10 meters high. We have various modules designed to fit specific field conditions. We also deployed our infrared learning module, IR210, which includes 6 independent IR output channels and can learn up to 2 to 4 IR remote commands for electronic devices like air conditioners, screens, and projectors. This allows centralized on-site control of multiple sets of equipment using our touchpad devices, which we will discuss next. Now, no more fumbling around in the dark for all those remotes. The touchpad device TPT70364 serves as an HMI for staff to control lights via the Light Control LC series and control electronic devices via IR210. We offer sizes in 2.8, 4.3, and 7 inches. We also offer free HMI Works development software specifically designed for our touchpad series. It supports C and ladder logic programming languages, ensuring ease of use for IT and PLC engineers. Moreover, users can preset environmental modes. In urgent and important meetings, you can quickly control all connected equipment with just one click. Our team also installed an industrial-grade ICANN LED display in the office. It shows crucial information such as temperature, humidity, PM2.5, and CO2 levels obtained from the CL212 industrial sensor. This setup enables staff to keep a conducive working environment. Besides the information mentioned just now, the LED display also shows alert messages about unusual server room access. You must be wondering why there is such an alert message. Now, we will move to the server room to get the answer. The monitoring system in the server room also controls lighting. Besides, the campus requested environmental control for the server room and server cabinets. So we deployed an IP-based Ethernet I/O module, an IoT edge controller, and an IP camera for security and safety monitoring. The WISE 5231 edge controller serves as the main controller in the server room, and a mobile data concentrator facilitates data transfer to the SCADA software. The first system highlight is temperature and airflow control, critical for ensuring optimal conditions in the server room. Maintaining the right temperature is essential to prevent equipment malfunctions. On the other hand, excessive cooling can also lead to unnecessary cost. 4 DL10 modules, which sense temperature, humidity, and dew point, were placed in key locations. 2 inside the server cabinets, 1 near the door, and 1 in front of an air conditioner vent. The WISE 5231 edge controller uses if-then-else logic to activate the IR71 to a universal IR learning module, adjusting the air conditioner's temperature and airflow. The DL10 shines with its compact size and magnetic mount, making it suitable for installation in restricted spaces. It can be quickly installed without any wiring effort. The second system highlight is access control monitoring. TET PD2R1 Ethernet I/O module connects to a security read switch, monitoring the opening of the server room door. When the door opens, the WISE edge controller activates the camera to take photos and sends notifications to the office. The alert message is then displayed on the icon LED display. If the door remains open beyond a specific time, WISE will alert the security guard to investigate the situation. Door opening and closing events are logged in the SCADA system for future references. So now we know why there is an alert message displayed on the icon LED display in the office. The icon series can store up to 1 to 8 general text messages and 20 priority messages. It allows instant display of emergency messages before returning to the scheduled ones. Similar to the first case study, we have installed smart power meters and power meter concentrators in the control panel to monitor power consumption in the office and server room. A PC with InduSoft serves as a host computer for remote control of campus equipment and devices. The left picture shows the home page featuring preset environmental modes such as work, meeting, and break. These modes allow for quick activation of lights, air conditioners, projectors, and other devices. Key monitoring factors like temperature and CO2 levels are also clearly displayed. On the right, we can see that centralized and remote control of individual devices is possible, along with scheduling functions available. On the left, we can see data visualizations such as chain charts of monitoring factors. Users can also check alerts and the power usage effectiveness. On the right, we can see live images captured by IP cameras installed in the server room and office. Alarm notifications are sent to a designated line group. For example, it alerts the staff in real time when the temperature exceeds 30 degrees Celsius. To help create a safer campus environment, we have to address areas where fewer people pass by, such as toilets, stadium changing rooms, and car parks. In such places, we can deploy the wireless emergency SOS system. The iSOS emergency call button wirelessly and actively uploads its battery and operational status to the wireless concentrator. The wireless concentrator supports up to 31 sensing modules and includes a relay output for connecting to alarm devices. Data is then sent to the Voice Edge controller, enabling connectivity to the cloud and alarm notifications to mobile devices. In case of emergency, pressing the call button activates the alarm device and immediately alerts security guards with alarm notifications. Here are some photos showcasing the SOS system installed in real applications. On the left, the indoor light charging emergency call button module is displayed. In the middle, there is a touch HMI device and an alarm device. On the right, the setup includes the power supply and the wireless concentrator. The system architecture is shown here. In the toilet, we deploy iSOS 109S2, indoor light charging and emergency call button modules. In the receiving station, we have a power supply connected to wireless concentrator, alarm device, and touch HMI device. The IWSN 200 series receives 433 MHz signals wirelessly, and then activates the alarm via relay output, as well as displays the emergency event on the HMI device via Ethernet. This comprehensive smart campus solution helps staff monitor power usage, security of the server room, safety of the toilets, and enables centralized remote and on-site control of equipment and electronic devices. Let's now explore ICP DAS products used for wireless campus streetlight monitoring. In this university, our task was to monitor streetlights installed across numerous sports courts, one sports field, one stadium, and the surrounding sidewalks. Due to the vast area and rugged terrain of the campus, we choose the ZigBee network for communication. Here are the application images. Each streetlight has 3 LEDs, and we have placed our ZigBee power relay module inside each streetlight to receive ZigBee command signals. Here is the system architecture of the ZigBee wireless monitoring network. We have deployed ZT2570 as a coordinator, as well as ZT2510 and ZT2060 as routers. Let's dive into the details of how it works. To begin with, we know that ZigBee has 3 different device types: coordinator, router, and end device. ICP DAS offers only coordinators and routers, not end devices, as end devices cannot forward data packets between devices. Our ZigBee coordinators include the ZT2550 and ZT2570. Our ZigBee routers include the ZT2551, ZT2571, ZT2510, and all other ZigBee I/O modules. The first aim is to optimize the lifespan of the streetlight LEDs. As mentioned, each streetlight has 3 LEDs, and the illuminance from just one LED is sufficient. Therefore, ZT2570 converters send commands at scheduled times to turn each LED on or off every hour. We also place ZT2510 repeaters to extend the signal transmission range. Even if there are physical barriers or obstacles, the signal can still be routed to the ZT2060 power relay module. In addition to turning the LEDs on and off, the Zigbee converter also sends commands at scheduled times to retrieve the LED status for remote monitoring. The Zigbee power relay module receives the command and sends a packet showing the real-time LED status, including any abnormalities. The repeater also plays an important role here to ensure successful signal transmission between the two modules. After looking at the field devices, let's see how we can connect the Zigbee network to the SCADA system and the cloud. In the center of the image, we have the powerful Modbus data concentrator, which is the MDC211ZT. This device can receive data wirelessly from Zigbee modules via Modbus RTU, as well as from wired RS485 and RS232 networks. The data collected from power meters, sensing modules, and Zigbee modules is combined and sent to the PC or HMI at once. We can also connect to the IoT Star cloud management software to utilize the key services introduced in the first case study for efficient and centralized Streetlight monitoring. In the event of any Streetlight malfunctions, notifications will be sent to the maintenance staff via SMS or line. In complex environments like rugged terrain or areas with public facilities, trees, and walls, we chose a Zigbee network for its higher communication success rates. On the left, the ZT2510 repeater extends signal transmission distances. In the middle, the ZT2510 repeater creates a mesh network and uses its hopping feature to forward data packets, even in the presence of obstacles. Some customers may wonder why the ZT2510 is a popular choice among the various Zigbee router modules offered by ICP DAS. The answer is its cost effectiveness. If your needs are to extend signal transmission and use the hopping feature to bypass obstacles, the ZT2510 is an ideal option. Other modules perform additional functions, so they are more expensive. ZT2510 can build a mesh network, but how does it work? When two or more ZT2510 devices are present, the network automatically selects the device with the strongest signal for data forwarding, while other paths serve as backup communication routes. The network also checks signal quality every 16 seconds and switches to the best route to improve data transmission success rates. How has the ICP DAS solution benefited the university? Firstly, with centralized monitoring, faults in any streetlight can be detected in real time, enabling prompt maintenance. Additionally, each LED light takes turns lighting up every hour to optimize its lifespan, resulting in cost and energy savings. Lastly, the improved street lighting acts as deterrent to crime. A study by the U.S. Department of Justice found that enhanced street lighting can reduce crime rates by up to 20%, further improving the safety of students and road users. In conclusion, ICP DAS provides one-stop solutions for schools and universities. We offer a 3-layer power monitoring solution that ensures efficient energy management. The power meter concentrator features 2 key capabilities: power demand forecasting and if-then-else logic control, helping to prevent exceeding contract capacity and facilitating unloading when necessary, which minimizes cost. We also provide a smart campus transformation solution focused on energy savings, centralized equipment control, server room security, and overall campus safety. Lastly, the Zigbee wireless streetlight monitoring optimizes the lifespan of streetlights, enables prompt maintenance, and creates a safer environment for students, staff, and road users. Our webinar is coming to an end. Thank you for watching. As usual, please scan the QR code to fill out the survey to receive our PowerPoint slides. Thank you. Now it's time for the Q&A session. Kevin will be here to clear your doubts.